Good morning, Algebra 2. We're going to get started in section 7.4, which is adding and subtracting rational expressions. Okay, so we're going to be adding and subtracting fractions. So don't freak out. Today's video might be a smidge long, but just make sure you're paying attention, and I'm really just trying to make sure you understand what's happening. So when adding fractions, you need a least common denominator. We're going to call that the LCD. This applies when adding or subtracting any rational expression. So let's just use numbers. If we have 1 over 2 plus 3 over 10, well, in order to add fractions, your denominators need to be the same. And in this case, these two ain't the same. We have a 2 and a 10. Those are not the same number. Please don't think otherwise. So we have 2 and 10. These aren't the same. So we have to break these down into their smallest bits. Well, 2 we can't break down any further, so it's just going to be a 2. But 10 we can break down into 2, oops, trying to do an arrow and a 2 at the same time, 2 and a 5. Now what I want you to do in order to figure out an LCD is first circle anything that's the same between the two. In this case, there's a 2. So my LCD so far is 2. And then you also have to include anything outside of your circles. Okay? Well, in this case, we have a 5, so we have to multiply by 5. So 2 times 5 means my LCD is a 10. So that means I need to make both of the denominators for the fractions a 10. Now, looking at my question here, we have 1/2 plus 3/10. Well, this already has a 10 at the bottom. So what do I have to multiply 2 by in order for it to become a 10? I have to multiply by a 5. But when you multiply, you have to do what you do at the bottom, you got to do the top. So you multiply all of this fraction, 5 by on the top, you multiply by 5 on the top and on the bottom. Whoa, I'm sorry. So this turns into 5 times 1 is 5. Tops times tops, bottoms times bottoms. 5 times 2, 10. And then plus that 3/10. And now that the denominators are the same, or the bottoms are the same, they're both 10, we can just add the tops, right? We can do 5 plus 3. Well, 5 plus 3 is 8, and then over 10. And that's your answer. Okie dokie. Let's see if my words don't fail me now. So let's just figure out straight up LCDs of things. So we have 1 over 5xy, comma, 1 over xy squared. So we're trying to figure out the LCD between these two bottoms. Now let's just look at the front. We're going to break it up into pieces. So we have 5xy. You can rewrite this as 5 times x times y. It means the same thing. Now let's look at xy squared. Okay. So we have x times y, and then this square means there's 2 of these y's. Okay, now what I want you to do is circle anything, any pairs that match between the top and the bottom. Well, both of them have at least one x, and both of them have at least one y. So anything you circle that has a pair between the top one and the bottom one, or between your two denominators, you're going to write just once. So we have x and we have y. Anything outside is also going to be part of your LCD. So we have this 5 here, and I like to write it up front. And then we have an additional y. So if we have an additional y, if I do y times y, what that really is y squared. So our LCD is 5xy squared. So anything you circle that matches between the two denominators, you write once. Anything left outside of the two denominators that isn't circled, you'll have to write as part of the LCD, okay? So let's look at this next one. We have 1 over x squared plus 10x plus 21, and then we have 2x plus 14. Okay, so looking at x squared plus 10x plus 21, we can factor that into x plus 7 times x plus 3. They both, so 7 times 3 gives us the 21, 7 plus 3 gives us 10. Then we factor the back one, so we have 2x plus 14. This factors into 2 times x plus 7. Okay, now between these two denominators that I wrote out their factors for, I'm going to circle anything that pairs up. Well, x plus 7 pairs up between the two. So when I start writing my LCD, I'm going to write the pair that we found between the two once. So we have x plus 7. Then you write anything else that wasn't paired up. So we have a 2, so I'm going to write it in that 2, and we have this x plus 3. So I write x plus 3. And that would be the LCD between these two denominators. All right, here we go. Now we're going to move on to actually adding and subtracting. So you're going to factor the denominators completely. Factor the bottoms completely. You're going to figure out the LCD. You're going to multiply each fraction by the factor they need to become the LCD on the top, and on the bottom. You can now combine the tops, make sure to use the correct adding or subtracting symbol, simplify the numerator if possible, so combine like terms, and multiply or distribute if you need, and then you should only have one fraction when you're finished. If you have two, something went horribly wrong. Okay, so let's look at number 1. We have 1 over x squared plus 5x plus 4 plus 5x over 3x plus 3. So what I'm going to do here is I am going to factor the bottoms. So we get 1 over x plus 4 times x plus 1. That's how you factor the bottom. And I'm just going to write these factors over here on the side. So we got x plus 4, and we got x plus 1. Now I'm going to factor the second fraction. So we have 5x over, they have a GCF of 3, so we have 3 times x plus 1. I'm going to write this on the side. So we have, 3 times x plus 1. Okay, now we need to figure out our LCD. Let's use some fun colors. I'm feeling funky. Okay, so between purple and orange, which ones do they share? Which one do they both have? They both have x plus 1. So my LCD, if they both have an x plus 1, we only write that x plus 1 once. If you circle it, write it once. Then there's also a 3 and an x plus 4. So I'm going to write the 3 and x plus 4. So this is my LCD. That means both of my denominators need to have all 3 of these pieces. All right, so let's look at the denominator of the purple fraction. So we have x plus 4 and x plus 1. What is it missing from my LCD here? It's missing the 3. So that means I multiply the top and bottom of the fraction by 3. Now, looking at the orange fraction, we have 3 times x plus 1. What in the LCD is it missing? It's missing the x plus 4. So you multiply by x plus 4 on the top and on the bottom. Okay, now you're going to have to use your algebra skills. So we have 3 times 1. That gives me a 3. And then I'm just going to rewrite my bottom like my LCD. So we have 3 times x plus 1 times x plus 4. The order in which you write your factors doesn't matter, okay? This could have been 3 times x plus 4 times x plus 1. It doesn't matter because you're multiplying. It's okay. Plus, I'm going to distribute my 5x into x plus 4. So that gives me 5x squared plus 20x over 3 times x plus 1 times x plus 4. Now, my denominators match. They have all 3 of the terms they need. So that means I can add the tops. Okay? So this gives me 3 plus 5x squared plus 20 over 3 times x plus 1 times x plus 4. Now, the reason why we write a parentheses around our back fraction is so we don't accidentally distribute wrong when we are subtracting in the future here. Because if you distribute a positive to a positive 5x squared and a positive 20, does it change its signs? No, it does not. So what you really have here is 3 plus 5x squared plus 20x. I'm sorry, 20. All over 3 times x plus 1 times x plus 4. Now you could leave this as the final answer. That's fine. But you guys need to be able to write in standard form, highest degree to lowest degree. I feel like I'm forgetting an x somewhere. I am. There's supposed to be an x after this 20. Right? 5x times 4 is 20x. Come on, Miss R. Plus 20x plus 3 all over, and we're going to keep the denominator or the bottom factored. We don't want to have to worry about multiplying all of that craziness. All right, moving on. We have 2x over 2x squared minus x minus 2 plus 4x over x squared minus 3x plus 2. Okay, now we're going to circle the pairs that are, or anything that matches between the purple and the blue. So what matches between the purple and the blue is, let me find my gray pen here, this x minus 2. Now since both blue and purple have them, for the LCD, we only have to write the x minus 2 once. Then we write whatever's left over that doesn't get circled as well. So we're going to write that x plus 1 and the x minus 1. Okay, so it doesn't matter the order of each parentheses as it goes, as long as you have x minus 2 and x plus 1 and x minus 1. So our bottoms need to match the LCD. Okay, they need to have all three of these terms. So purple, we have x minus 2 and x plus 1. So the only one that is missing is this x minus 1. So that's what we're going to multiply to the top and the bottom of this fraction, of the purple fraction. Now looking at the bottom or the denominator of our blue fraction, we have x minus 2 and we have x minus 1. The only thing that we're missing is x plus 1. So that's what we're going to multiply to the top and the bottom, because what you do to one side of the fraction, you got to do to the other. Okay, now we're going to do some algebra mathiness. So let's use a fun color. Let's use orange. So we're going to distribute this 2x to x and negative 1. And that becomes 2x squared. Well, let's keep it a purple, huh? So that becomes 2x squared minus 2x over, and then we have all three of our terms. We have x minus 1, x minus 2, x plus 1, plus. Now we have our blue fraction. So we're going to distribute that blue 4x to both terms on the top. So that becomes 4x squared plus 4x. And then we have our three factors on the bottom. X minus 2, x minus 1, x plus 1. Our denominators now have all three of the terms that we need that match the LCD. That's what our goal is, to make sure we have all three of those. So now what we do is we add the tops together. Okay, so when we rewrite this, we're going to rewrite it so that they both have the same bottom. So we have our LCD for the denominator, for the bottom. Then we have 2x, so I'm going to write this in purple just so we keep with it. We have 2x squared minus 2x plus, and then we're going to put our back stuff in a parentheses just so that we make sure we keep that skill going. We want to make sure we don't make any silly errors. Okay, so when we distribute to a positive to terms in a parentheses, it doesn't change the signs. So when I rewrite this, I'm going to write everything in one color going forward now. So when we rewrite this, we have 2x squared minus 2x. That doesn't change. But when we distribute that positive, everything, all the signs in my fraction or inside of my blue parentheses stay the same. So if this was a positive 4x squared, it stays a positive 4x squared. When we do a positive times positive 4x, this stays positive 4x over x minus 1, x minus 2 times x plus 1. Now we're going to combine like terms on the top. So we have a 2x and a 4x. So that gives us 6x squared. We have a negative 2x plus 4x. Excuse me. So that gives us a plus 2x, all over our LCD, which was x minus 1, x minus 2, x plus 1. And that's it. Now what's nice about when you're adding and subtracting is I'm not going to be asking you to figure out the domain. Okay, so I'm not asking you to figure out the domain. When you're adding and subtracting, just add and subtract. All right, for number 3, we have 3 over 5x squared plus 2y over xy plus x. So we're going to rewrite our denominators. Our denominators. So my blue, we had 5 and x and an x. And then from a pink, we had an x and a y plus 1. So we're going to circle anything that both blue and pink share. Okay? All right, so blue and pink share an x. And that's it. So when I write my LCD, I'm going to have that singular x that we circled, but we have another x. Then we have 5, and then we have y plus 1. So I'm going to clean this up so it looks a little bit nicer. X times x becomes x squared. So I'm going to write a little equal sign here. So we have 5x squared times y plus 1. So this is our LCD right here. Well, maybe I shouldn't box it because it's not the answer, but this is our LCD. So that means that both of our denominators have to have 5x squared times y plus 1 in the denominator. So we have, for the blue, we have 5 times x times x. Well, that's 5x squared. So all it needs is this y plus 1. So we multiply by y plus 1 on the top and on the bottom. And then let's look at our pink fraction. We have an x, we have a y plus 1. Okay, so far we have an x and a y plus 1. We need another 5 and an x in order for the denominators to be the same. So we're going to multiply by 5x on the top and on the bottom of the pink fraction. All right, so now we're going to do some distributing. This gives us, if we distribute 3 onto the top, we get 3y plus 3. You multiply the tops, and then you just leave the denominators as our LCD, which in this case is 5x squared, y plus 1. Then we have our plus sign. That doesn't change. There's always going to be a plus sign. And then we have our pink function. So we have to distribute that 2y. We have to multiply 2y and 5x. Well, that becomes 10xy over, and now we have all of our pieces for our LCD. So it's 5x squared, y plus 1. Our denominators are the same, which is what we want. So that means we can add our tops. All right, so I'm going to keep with it. We have 3y plus 3 plus, and then I'm going to put this in a parentheses just so that we can keep that skill because it's going to be very important for when we subtract. Over, and then our LCD, which is 5x squared times y, let's make that look like a square, times y plus 1. So if I distribute this positive to this 10xy, it doesn't change the sign. So what we really have here is 3y plus 3 plus 10xy over 5x squared times y plus 1. Now there's no like terms to combine on the top, and so that means we are finito bonito. All right, I feel like there's more. Okay, there is. Okay, so we have, for number 4, x over 2x plus 4 minus x plus 3 over x plus 2. That minus sign is going to freak you guys out, but don't let it. Just stay with me. So let's write our two sets of factors that we have. So we have our green, which is 2 times x plus 2. And then we have, for our purple, we have just x plus 2. So circle the pairs between green, or what both green and purple have. Well, green and purple both have an x plus 2. So our LCD definitely has at least one x plus 2. And then whatever's left over. Well, in this case, we just have a leftover 2. Now, let's look at our green and our purple. Our green, does it match our LCD? It sure does, so we have to do nothing to change that. But let's look at our purple. We have just an x plus 2, so all we have to multiply by is a 2 on the top and on the bottom. Okay, so this leaves us with our green fraction, which is x over 2 times x plus 2, minus, now we have to multiply that 2 on the top, okay? So we get 2x plus 6, and then over our LCD, 2 times x plus 2, because now it has all the pieces. Our LCDs match, so now we are going to combine our fraction into 1 with that minus sign. So now we're going to subtract x. We're going to take x minus 2x plus 6. So we have 2 times x plus 2. Up top, we have that x. Then we have that minus sign. Okay, this is where that parentheses stuff is going to be important that I kept saying for when we were adding. Then we have 2x plus 6. So when I distribute this minus sign inside of my parentheses, it flips all the signs. So now what I have is x minus 2x minus 6. You'll remember this first one, but make sure to remember any terms that are behind it as well, okay? You gotta remember. That is a very long minus sign. Over 2 times x plus 2. So now we're going to combine like terms. X minus 2x is a negative x minus 6 over 2 times x plus 2. And that is your final answer. All right, let's see if we have any more examples. We do. So we have 2x minus x squared plus 3x over x squared plus 4. Now, here's the thing. X squared plus 4. X is a perfect square. 4 is a perfect square. But, we have a plus sign, so we cannot use the difference of squares. Now, 2x doesn't have a denominator that we have written, but we're going to write it as a fraction. We're just going to write it over 1. So that means my LCD is just this x plus 2 from the only fraction that we have. I'm sorry, x squared plus 4. Sorry, I have 2 on the brain. So my back fraction has x plus 2, but my front that I remade into a fraction doesn't. So I need to multiply the top and bottom by x squared plus 4. So I multiply by x squared plus 4, multiply by x squared plus 4. This gives us, so we're going to distribute the top, so we get 2x times x squared gives us 2x to the third. 2x times 4 gives us plus 8x over x squared plus 4. Then we have our minus sign. Then we have x squared plus 3x over x squared plus 4. This didn't change. Our denominators are the same, so now we can subtract the numerator of the front minus the numerator of the back. So we get, let's write this as a singular fraction now because our denominators are the same. So we have x squared plus 4. Then we have 2x to the third plus 8x minus, and then put in parentheses your back terms, x squared plus 3x. So when I distribute that x to both terms, it flips all of the signs. So we have 2x to the third plus 8x minus x squared minus 3x, all over x squared plus 4. Now we combine like terms. There's no like term for 2x to the third, so it just stays 2x to the third. 8x, well, let's go in order. So we have 2x to the third, so now we start with our square. Minus x squared, there's no like term, so it's a minus x squared. 8x, a positive 8x minus 3x gives us a plus 5x, all over x squared plus 4. And there you go. That is your final answer. All right. I think that is all the examples. So your homework is 7.4 worksheet. If you have any questions, feel free to ask. This is a tougher lesson, so make sure you review anything that you need to look at. All right, have a good day, and I'll talk to you next time.